Cybersecurity, Vigenere, Cipher, Encryption and Decryption. Group members Clyde, Hunain, Rayan, Muhammad Hamid, and Saram Khan. Introduction. The Vigenere cipher is a technique for text encryption that employs a sequence of distinct Caesar ciphers determined by the character patterns of a given keyboard. A single Caesar cipher cannot match the strength and the difficulty of the Vigenere cipher. In our project, we're going to be taking the user input by asking for two possibilities, either encryption or decryption, the key from the cipher from the users, the plain text from the user. All of this, when collected, the program is going to provide them with the encrypted and decrypted text. The project scope and objective. Implementation of the Vigenere cipher. The primary objective of the project we're working on is to code the Vigenere cipher in Python that enables users to both encrypt and decrypt message via a specified key. User interaction and input management. The application guides users through the encryption and decryption process by asking them to select one. Additionally, it mitigates any concerns linked to case sensitivity by transforming all characters to uppercase, ensuring there's uniform in input and results. Important roles. Key generation. A function in the code generates a key based on the user's supplied key and the length of the plain text. The project's instruction goal is to provide users with a hand-on grasp of traditional encryption principles, particularly as they relate to Vigenere cipher. Hello, this is Mohammad Afzal, ID 8215832. Today I'll be explaining about our Vigenere code that we've done. So I have the code open up in VS Code as a Python file, and basically I'll be running it and I'll be showing you that it works perfectly fine. So we'll run it, and you can see it gives us two options: encrypt and decrypt. E for encrypt and DE for encrypt. So first we'll encrypt our code, which one we press over here, and then let's just encrypt the word password, and then let's enter the key. So you can see it gives us the encrypted, which is this. Now we'll run it again, and this time we will decrypt it. So DE, and let's just type in the encrypted part that we got, and then we'll enter the key that we entered before, and then we got the word password. So this works. So this shows that our code works perfectly fine. Let's do it again, but this time with another password. Press E, and then this time let's make the password called game. Let's make a shorter one, and let's press the word key. And this is the encrypted version this time. Now let's enter it again, and then DE, and then QEKO, and then enter the key and the word game. So this shows that our code is working perfectly fine, and it's almost a simple Vigenere code, showing that it can perform encryption and decryption. Result and analysis. The Vigenere cipher was successfully executed in our project, giving users an easy-to-use interactive tool for encrypting and decrypting text. It was necessary to construct the key function. The key function generates encryption and decryption to guarantee that the Vigenere cipher method was applied correctly. The program's usability was improved through user interaction and input handling, and the possible case sensitivity concerns were addressed by converting all input to uppercase. Intensive testing was conducted to validate the accuracy of the result, including a range of situations including varied length, key lengths, plain text, and ciphertext. In cryptographic implementations, extensive testing is vital, and in this scenario, it contributed to ensuring the accuracy of the encryption and decryption procedures carried out by our team. Conclusion and what could be improved. In conclusion, by giving users an easy-to-understand and engaging platform to investigate traditional encryption ideas, the Python version of the Vigenere cipher has succeeded in achieving its instruction goals. Through intensive testing, the project successfully guides users through the encryption and decryption processes, guaranteeing accuracy. The focus on clarity and simplicity increases the effectiveness as a teaching tool for the principles of encryption. Potential for development which we could have improved on was improved user guidance. Despite the program's ease of use, more instructions or prompts should be added to help users comprehend the importance of key generation and how it fits into the encryption processes. We could have also added a graphical user interface. Adding a simple GUI can improve the program's usability by making it easier to use and more aesthetically pleasing, as you don't have to be as tech savvy to use it anymore.